Let's take a look at the Raspberry Pi Pico in a build called the PicoMiteVGA. It's a Raspberry Pi with VGA output, and it's featured on Jeff's projects page. It's a very nice page with an extremely nice user's manual. Take a quick look at that too. And it turns the Raspberry Pi into a computer that boots BASIC on a VGA monitor with a nice setup of 16 color graphics, and it takes a PS2 keyboard. We'll build it with pieces that Landboards produces and sells, either as bare cards or as assemblies, but completely built from parts that I have. It's got an SD card, so it's really like you had a retro computer, as they describe it here, from back in the 80s, maybe late 70s, but with a real nice setup of being able to store your programs to the SD card and do fun stuff. It's a pretty full-featured BASIC too. It's not the BASIC your dad ran when you were a kid or tried to force you into running, as I did with one of my kids, who incidentally became a programmer, so worked out in the end. But he describes it as the worst experience of his life, me trying to get him to program in BASIC on an old computer. But anyway, that's a digression. The PicoMite boots directly into the BASIC prompt when you turn it on, so it's that experience of the retro computers back in the 1970s and 80s when you turn it on and you didn't have to wait for 5 minutes for the thing to boot and do an update and all that other stuff. It just pops right up on. The other cool thing about it that isn't really detailed here is that you can run, instead of the PS2 keyboard, you can run over the USB port that's on the Pico card itself for your keyboard input and still get it to go output to the VGA to screen. And the text side will go to your local screen as well. It's a pretty full-featured BASIC. 64-bit integers is quite a bit bigger than the 16-bit BASIC that most of us probably would have had back in the day. It doesn't require line numbers. It's very quick. It describes itself here as 100,000 lines per second. It might be true. Didn't do any performance testing. But it talks quite easily to the SD card, to the PS2 keyboard, to external peripherals as well. They've got a really nice library in there for I2C, and maybe we'll take a look at some of the demos that I wrote for that. Let's take a look at the other features here. As I said, VGA 640 by 480, or in 16 color mode, that's in monochrome, or in 16 color mode 320 by 240. So a pretty classic setup for back in the day. The RP2040 processor that's used on the card, on the Pico card, has two processors inside of it, and one of them is used just for drawing the display, that along with a lot of DMA to move things around on the screen. I think the coolest part, here really, that just gives it a leg up on what you would have had back in the day. I mean, back when I was a kid and got my first computer, I had to buy a floppy drive that was a couple $100 extra, and then if I wanted a second drive, it was a lot more, and it just didn't have the capacity to store a lot of stuff and all the issues that come with floppies. But this thing, you can move files back and forth between your PC because they're formatted in FAT16 or FAT32. I've got a 32 gig SD card plugged in here, and it just worked fine, no issues at all. And I've moved programs back and forth that way. There's also an X modem function built in, so you can download programs over the USB by X modem. You can sit and type on the PS2 keyboard, see things on the screen, upload or download via X modem, and that works just flawlessly. It's a pretty simple card, or designed and built, or ordered a card. Hasn't come yet, but I'm going to build this up as a card, hopefully, or offer it by Landboards. There's a few builds. They have 3 different example builds. I think I've taken a look at what they had and saw stuff that I liked and didn't like on each of them, and sort of took a best of breed for it. Maybe I'll do another video on that card after it comes in and gets built up. You can hook up a real-time clock. I tried hooking up a DS1302 to it, and it didn't work, so I think it's going to require a 1307, which I think is about $5 on eBay. Just haven't pressed the trigger to buy that yet to try it out. If I had one sitting around, I would give it a try. The work, Jeff Graham wrote the basic interpreter. It says Peter Mather did the project. A lot of work here. PIO compiler, the Raspberry Pi Pico, inside of it has 8 little programmable I/O processors that run and do stuff. And then there's a VGA driver in it as well. So it looks like it's a collaboration of putting pieces together of that other people did as a very neat little project. It's free, of course. They say the source code is up here. I haven't taken a good look at the source code yet, but it looks like there's stuff up here. I don't really see the files, build the files. So I don't know. It doesn't look like it's the source code to me, so I don't quite know what's going on there. It might not really be up there. Let's take a look at the user manual. It's a very nice manual, 139 pages long. Some really good descriptions here. Same things off the web page. The connections to it are really pretty simple. They show how to hook up the VGA monitor. I didn't do it this way. The card that I have is a little bit different. I didn't think the diodes were really necessary. It looks like they're doing it to clip the video level. And I think if you just pick the right level resistors and you know a VGA monitor has 75 ohm termination, you can make a nice proper 0.7 volt peak signal. So that's what I did, and it seems to work just fine. There's one bit for red, 1 bit for blue, and 2 bits for green, and that gives you the color scheme that they have set up. Let's see what other things you can hook up. So the keyboard is pretty straightforward. They've designed it to use 5 volt keyboards. A lot of PS2 keyboards will run at 3.3 volts. I've got a couple here that do, and I've got a couple here that don't. So having that feature is pretty nice. The little card that we have does that level shifting. A little Landboard's PS2 keyboard card does that level shifting. So I didn't have to use the MOSFETs to do that, but this is one of the schemes. You can also buy a little card from Adafruit that does level translation as well. Takes a little bit of hooking up. But basically you drive the 5 volts out to the keyboard. The translator's got 3.3 volts on one side, and it turns it into the 5 volts the keyboard wants to see. The SD card hookup's also pretty simple. It's just a normal full-size SD card slot is what I'm using, and it hooks up the SPI signals, the MISO, MOSI, clock, and chip select, and it runs at 3.3 volts. So I've built a version of my SD card, Landboard's SD card, that does just 3.3 volts, and we'll take a look at that as well. And that's really about all you got to do. You can buy a card that does it as well. The program's got a nice full screen editor for editing programs. You notice you don't have to put line numbers in here. They put indents in this particular case. You can do labels for the go-tos and the go subs and that sort of thing. Comments aren't REM. They're this little single quote here. So it's a little bit different in syntax, but it should be very familiar if you've done basic stuff in the past. Looks like they're rolling in nice little features like the ability to pass parameters to functions and to call a function without even a go sub. So it looks like this check valid move is getting PR, X and Y passed to it and doing a check on that. So it's very nice sort of extension on basic. Written a little bit of programs in it, found it extremely easy for I2C. That's kind of what blew me away. Quite a bit of graphics capacity here. You can have different font sizes in it. There's a couple of demos out there for it. Trying to find more software for it. There doesn't seem to be a ton of it. It does seem to be quite easy to run, and I'm sure with a little bit of work, just about anything that's written in BASIC could be adapted. One of the things that I did put on here is the sound. There's a little low-pass filter circuit here. Sort of mixed feelings about this particular choice of circuit. It works. It takes the square wave that seems to always be on the PWM signals, whether you're driving sound or not. It's always putting out a square wave. But because it's at such a high frequency, it filters most of it out. I think I can hear a little bit of a hum out of the speakers, but it does seem to be not really an issue. Let's see if we can play some sound and see how that sounds while we're here. I apologize for the font size. I'm using Terraterm as the terminal because it has Xmodem built into it. And the font list just doesn't seem to be, doesn't look like it goes beyond 14. There might be some other choice that gets you there. That's a little bit frustrating for making videos, but hopefully it won't be too bad. I can see the same thing on the VGA, but I don't have a good capture set up for that. If we do files, it's like doing directory and shows the things that are on here. Right now I'm in the basic folder that supports folders just like normal. If we load up a sound, don't have to actually load up a sound. I've got that. I do ch directory or change directory. Got to put things in double quotes. If I go back a directory, up arrow works also. So you got the standard, normal, easy to move around things. You don't have to retype a line. You can easily fix stuff. Got a wave folder here. Hopefully I won't get flagged by YouTube, but this is shareware public domain wave file. Oops. It's wave. CD. Oh, CHDIR. Keep going back to DOS days. WAVE. So there's my wave files. If I do files, back a nice list of the files that I've got up there, and let's pick one here for fun. I think it's let's see what they say. The play command, play wave, and then the file name. So it'll be play wave, and let's go for the sample 9-second one. Dash 9s.wav, and the commands can be typed in upper or lowercase, but I think the file names have to respect the case of the file contents. Let's see what it sounds like. Hopefully it'll come out okay. Let me turn up the sound a little bit. Crackly speaker knob. Alright, that was pretty quick. Let's try a little bit longer sample here just for fun. This one's a little bit better, I think. I like it. It's pretty good. Alright, let's go ahead and stop that. I believe it's play stop. Alright, so the sound just works. Like I said, there's a little bit, if you put your head up to the speaker, a little bit of a sort of a hum that comes off of it. If it had a better filter, it might be able to take care of that. Let's go ahead and take a look at some of the hardware that's used here for the LAN boards cards that exist. So I could just wire this together. It wasn't any real huge effort. First thing to take a look at is the Pico itself. I mounted it on one of these little circuit setup.us cards. Now I'm having a hard time finding again the one that I bought, which is the one with this little DC power jack, but there's other options out there. So I put the Pico, I put it in a socket, a female socket, or a set of pins, 2-pin headers, and then I mounted males on both sides so I can get to any of the pins that I want, and then I mounted power and ground strips down the side. So this turns the ability to easily pick off power and ground and then pick off any Pico signal, and it mounts it in something that's fairly solid, and I can easily cable up to it. Second card that I used was my VGA X49 card. Built a version of it that just had the 4 resistors for the red, 2 for the green, and 1 for the blue, so it was pretty straightforward. The resistor values I picked were a little different than what they had because I wanted the 0.7 volts without doing any clipping through diodes. So I used 270 ohms for the red and green, or red and blue. And for the green I used 390 for the more significant bit and 820 for the second bit. And the calculations show that it's pretty close to 0.7 volts in both cases, and they're off-the-shelf sort of standard values when you go to do something. And they don't exceed the output current. The part, I think it puts out 12 milliamps, and each of them are taking 10 milliamps. So for the PS2 side, I use this little PS2 X49 card that I have. I only populated one of the 2 US or PS2 jacks. It's got a voltage translator sitting here in the middle. Version I have is a little bit newer. It's got pull-up resistors. I don't think they're necessary because I think the part does that essentially, but that was the one I picked, and then you hook up the 3.3 volts, the 5 volts, and the clock and data from the keyboard on the ground. So it's a pretty easy cable up. Yeah, like I said, that's really all there was to it. And I built a build of this SD card, the SD underscore card underscore X49 card. It's got a full-size SD connector on it. It's got an LED that indicates activity, and that does show up when the card's accessed. It's got a little another little level translator that turns the 4 signals into 3.3 volts, and normally it would, but in this case it's not necessary, so I just jumpered this no 5 volts and didn't populate the regulator here. There's commercial cards to be able to do this as well, but what you'll see in a minute here is why I really like this setup. I can easily stack all these cards together in a real nice little way. Used another Landboards card, the Grid 49. It's a little breadboard card to build up this audio filter circuit that they had, and put the resistors and capacitors on that card. And then I mounted a regular 3.5 millimeter jack on the card. I did a little simulation just to see what sort of noise you would see if you put in the square wave that I was measuring, and it looks like it's a very small amount of noise when it's just running all the time. I'm not sure why they don't shut them off and make sound go away and just make it DC level, but that's how they've got it set up. Little simulation run in LT Spice. So I was pretty happy with that. Made a little chart here of the cabling that goes for it as well. So here's the card stack up, the Pico here on the left, little DuPont cables going off to the various cards. These DuPont connectors are 1x10, so I'm using 4 of those to connect up to all the signals. I tried to be halfway sane about the color code that I was using, but if you look up the stack up here, you can see the 32 gig SD card on the SD card adapter. PS2, I replaced this with just the single purple, which is the keyboard connector. The VGA card here as well, and the hacked up or built up little audio circuit with the 3.5 millimeter jack on the top, and that one's got a little right angle pin header on it. So everything comes into pin headers in the back of the cards, and they're spaced apart from each other by little 440 standoffs that I use different size standoffs depending upon the card stack up that I have. I don't have, as I said, a good way to capture a VGA video, but I did run one of the little sample programs that I found out there. It might have come with the setup, and it's a Tetris clone called Blocks, and it's very addictive. I probably put 8 or 10 hours in on it the last couple of days. It's definitely taken over my interest, trying to beat that number. It's a lot of fun. It feels just like Tetris. Doesn't support sound, but it's fairly amazing. Very nice looking little blocks and all the colors showing off the color modes and all that sort of thing. You can also see here the different font sizes and colors. Large font here for the score, smaller fonts for text that are on the screen. Very full feature little setup that they've got here. I'm kind of surprised how good it is. Alright, let's take a look at how it does the I2C on a little demo card I've got set up here. I think it's pretty nice. It's not going to be a great video. I just don't have a setup at the moment for capturing things like this. What did I do wrong? Files. Where am I? Make sure I'm in the right place. chdir. Go back a directory and do files again. Just do up arrows. It's easier. Oh, nope. Files. And it's basic. CD basic. I keep forgetting it's CHDIR. So used to so many years of doing DOS stuff. CHDIR. And files again. Files. Wow, you gotta watch all my typos. So I wrote a little program here for a 16-bit I/O card that I have. It's called the Proto 16 I2C card. I've just put 16 LEDs on it. Let's take a quick look at the card before we run the video. The Proto 16 I2C card is this nice little card that's got a MCP 23016. It's a 16-bit port expander that takes in the 2-wire I2C and turns it into 16 digital IOs. The card does have a DB25 on it, although for this demo I'm not using it. I've just mounted 25 LEDs on the card, but basically you just hook up ground and power and then the SDA and SCL signals from the Raspberry Pi Pico into the card, and I picked a couple of smart pins hopefully to do that on, and they worked fine. And you can write all 16 bits, you can read bits. I've written a couple of demos reading from another card. This one just has LEDs, so it's all I can do is write. Let's go ahead and run that program. To load a program, you just type load in the file name. As I mentioned, it needs to be in the proper case for the way the file is stored. So this is GPIO16-01.bas in lowercase. And it doesn't even take maybe a second to load. It's not a huge program. Let's take a look at the editor real quickly here. Type edit, it's built-in editor. Color-coded scheme going on here, which I really like. I've got all of the comments in yellow, the defined numbers here in green. What is that? Is that ampersand H for hex? Yeah, that's the hex. All the MCP 23017 registers defined. Let's see, we can scroll up and down in the file with the scroll wheel, although it seems to work backwards, but you can move with arrow keys on the keyboard too. As I say, all this is incidentally showing up at the same time on the VGA screen. I'm just running it here because it's easy to see. This particular code does some setup of the MCP 23017, setting up the directions as all outputs, and it writes out a 5.5 in the beginning, and then it writes out an AA or alternating pattern on the sets of lights, and then it clears them, and then it'll bounce across the LEDs. And that's really all it does. It's a pretty simple little program. It does sit and look for a key. If you hit a key while it's running, it'll stop. Hopefully it'll print something up on the screen here. Let's go ahead and hit F1 to exit. Or I can escape because I didn't change anything. If we type run, let's see what it does. Hopefully that gave you a little taste for what the Raspberry Pi Pico hardware is capable of doing, and in particular the beauty of their little project here, Jeff's project and the other contributors, for making a basic for the, I'll say for the 21st century even, because it's pretty full capabilities. I was really surprised. One of the things that really surprised me is how easy it was to do the I2C on here, because I fumbled around with I2C on Raspberry Pis, and that's a lot of work. On Arduinos, not quite as bad, but it can be fumbly, especially talking to a more complex part like the port expander. You have to try to figure out how to do it. Those parts act more like their memory. You have to give them an address, not just the I2C address, but a register address inside, and then either do a read and write. And if you're doing a read, you have to terminate the write of the address and do a read without stopping the transfer. So a little bit of tricky stuff going on there to do that. The code was actually quite simple for that part of it. Let's go back and take a look at the code again. And it's just the difference between a 0 and a 1 in the right place. I don't have it. It's in the other example. Pardon me. I've got another example up. I'll try to put a GitHub link up for my card that reads 4 switches and writes the 4 LEDs, the other little card that's next to this Proto I2C card, Proto 16 I2C card. And that particular one, you just basically, for the first transfer, do 0 for continue or 1 for continue, and on this second or any read transfers, you tell it how many bytes you want, and you just it'll just terminate at the end if you set the other value. So quite easy to do I squared C. Again, surprising. Really fumbled hard on it with BeagleBone, Raspberry Pi, Arduino, other places I've tried to do it. MicroPython, I don't think it was quite as bad. I was able to write quite a bit of MicroPython code. I'm more impressed actually with this project than I really at all expected I would be. You have quite a bit of space. It looks like here I've loaded a program that's pretty small, 74 lines. It only uses 2K. I think you get like, what's that, 108K total of space. Plenty of space for variables. Didn't really use any here at all out of the space. It rounds down. 140K of variable space. So in spite of the fact that it's driving a VGA display screen, it still has quite a bit of capacity left for running BASIC, which I think that's a good trade-off. I tried some MicroPython examples on the Pico, and it just seemed to run out of steam. I ran some things from last year's advent of code, and I could do the more simple examples that I have, but the bigger things it just sort of choked on. So I think whatever they've done here has been very efficient. Maybe it's just the much smaller, more constrained language that you get with having BASIC than you would have with having MicroPython. But either way, I think it's a good trade-off. I'm going to try to do some more things. I now essentially have card tests for my I2C IO8 card and for this Proto 16 card. Nice little tests that I wrote for them, and this thing could be a real nice little standalone test station written in BASIC in the year 2022. People are still writing BASIC. Gives me a little more respect for it, and definitely brings it up somewhere into the 21st century. Thanks for watching. I hope you got something out of the video. I hope it wasn't too long-winded, but you can find the cards for this project, the VGA card, the SD card, the PS2 adapter card. I sell all of them on Landboards, sells them on a store on Tindy. I'll try to put a link in the end here for that. You can probably find in the channel information as well. But anyway, thank you for watching and have a great day. If you want more information, you can see our wiki pages for these products, and we have YouTube videos on them as well. We have a store in Tindy where we sell all of our cards. Thanks for watching our video, and if you enjoyed it, don't forget to like, share, and subscribe.